Given the quadratic equation ax squared plus bx equal to 0, where a, b, c are the constants, a not equal to 0, show the roots. This is the roots of the quadratic equation is given by this formula. So we are going to prove this formula. So step 1, we will have to start with very basic general form ax squared plus bx plus c. So start with the general form. Okay, make sure it's in general form. Okay, step 2, we divide by a. We divide by a for every term. So we divide by a, divide by a, divide by a, divide by a. So we will get x squared b over ax plus c over a, and 0 over a you will get 0. So we will simplify to the equation like this. And then we need to do completing the square. Right, so we are going to do the completing the square. How to do the completing the square is we need to identify the half of the b, and we need to take b over a. This is a half of the b is a coefficient of the x. Okay, it's not a small b, so half of the b over a is b over 2a. So actually by right we will write as this x over square plus b over ax. We need to plus with the b over 2a. Okay, we need to plus with the b over 2a, and then square, and immediately we will minus out b over 2a square plus c over a equal to 0. That's why we will get a perfect square for this. So we'll get x plus b over 2a, but we still have the minus b over 2a there, and square plus c over a equal to 0. Got it? Okay, we have the perfect square already. So we can shift this number to the right and this number to the right. So that's why we have negative c over a and positive b squared over 4a squared. B squared, we square the b, we square the 2, we get 4, square the a, we get a squared. So finally we get the equation like this. Okay, so we will have to square, we have to make the denominator the same first. So we times with the a, times with the a, times with the 4, times with the 4. So that is why we got the 4ac here. Here we got 4a squared. Finally, we will make the denominator the same and we will join them. It becomes b squared minus 4ac over 4a squared, because the denominator are the same. And because there is a square here, so we have to square root the whole thing, square root. So finally we have a plus and minus, don't forget. So that means we have two answers. One is actually is a negative one, which is this one. We will have the negative one, and the other one is a positive one, which is this one. Right? So we have two answers, positive and negative. Right. So in short, we will have two answers for the x, for the roots. B squared minus 4ac over 2a is actually the answer will come with a plus minus because we square root. So if we simplify this answer, we will get the answer after you simplify to the simplest form will be this one. This will be the answer. X equal to negative b plus minus square root b squared minus 4ac over 2a. Alright, so that is how we prove the roots of the quadratic equation. Again, I just summary the step. In order to prove this quadratic equation, we're going to show the root is this one. First of all, we must have the general form. Okay, we must have the general form. And then we need to divide by a. After we divide by a, we plus b over 2a square and minus b over 2a square here. In between here, this one I add one step for you. You will write x squared plus b over a x, and then you will plus with the b over 2a square, and you will minus b over 2a square, and plus with the c over a equal to 0. And these three will become a perfect square, which is this one. And the minus b over 2a is still there, it's a minus. So the c over 2a we just copy, and then we just simplify, and then we shift to the right. After we shift to the right, we need to square root. After we square root, we got plus minus, we need to minus the b over 2a, and then we will simplify, we'll get two answer, negative b plus minus square root b squared minus 4ac over 2a will be the roots for the quadratic equation. This is a syllabus for the proving of the Form 4 syllabus and also Form 5 syllabus. So I will start with the first proving, start from Form 4. Given that function fx equal to x squared, and the x is greater or equal 0, and gx is equal to negative square root x, and the range of x is greater or equal 0. Find composite function fgx and gfx, hence determine whether gx is the inverse function of the fx or not. State your reason. This kind of question is called proving. So, solution. First of all, we have to start with the fgx is equal to the function f with the object gx. Alright, and we will substitute the function gx, which is negative square root x, inside, and the whole function will be square, and we will get fgx equal to x. Alright, first thing we will start with this fgx equal to fgx, and then let's go to the function given. Gx is negative square root x, so we will substitute in. Need to square the whole function of the gx. And if we simplify, negative with square, we get positive, right? Square root x times square root x, you will get x. So that's why you prove that you got fgx equal to the x, which is the object. X is the object. Gfx. Okay? Composite gfx. And then the gfx, the function gx is given here, right? It's negative square root x. So we have to use a function g, and we will substitute the fx. Fx was given x squared, right? Here. So the object now is a fx, and the function is a g. So negative is there, we will get negative x, right? So the gfx is given answer negative x, because gfx not equal to x, right? So gx is not the inverse of the fx. So in order to prove that it is the inverse of the fx, we must show that we will get x. Since we are getting gfx is equal to negative x, so conclusion is gx is not the inverse function of the fx. The first proving is proving the fx equal to x squared and gx equal to negative square root x. Find fgx, find gfx, and then determine that gx is the inverse function of fx or not. State your reason. So we found out that gx is not the inverse function of the fx, because if it is the inverse, you will get the x.